This lecture will focus on the application of cloud computing, and we'll see it as a natural progression from grid computing. So the key objectives are to give an introduction to cluster, grid and cloud infrastructures, to define some of the applications of grid computing and its advantages. Then we'll look at how we can scale this into a cloud infrastructure, and finally on to the usage of the Amazon Web Services, including S3 and the EC2 cloud. And as part of this, we'll look at the application of what are called RESTful web services. Okay, so let's look at how we've generally evolved in computing. So initially we had mainframes, and these mainframes were connected to by terminals. So these provided centralized processing, centralized storage. The terminals themselves had very little computing capacity. So as the microprocessor came along, what happened is that we now had the power of what we had in a mainframe with inside a standalone computer. So we generally installed applications locally, and we had our storage also done locally, and then these standalone computers connected through a network to give them interconnectivity. So as more and more computers arrived, then it became more and more difficult to manage the software which was installed on these computers. So we generally centralized our applications and our storage around servers. So then we had what was called a client-server architecture, where clients connected to a server and then got resources from them. This was typically for file servers, for email, for web, and so on. The next major jump is coming with what's called service-oriented architecture, and with this we provide services, typically through web services, across the internet, and then our terminals, our clients, can connect and consume these services. In this way, it's almost like going back to the original mainframe concept, where we can have very lightweight, thin clients which actually build their applications around these services. And as long as we can get connectivity onto the internet, then we can consume these services. So generally we're moving away from what's called a thick client. With a thick client we have our hardware, we install an operating system on it, and then we run software applications and services on the operating system. The move is now towards using virtualization. With this we can install a virtual server such as VMware or virtual PC, and then with inside there we can run multiple operating systems, all of which are isolated from each other. So we can actually have our operating system installed, or we can have bare metal virtualization, where the VM server runs, the virtual server runs directly on the hardware. So this is leading to what's called thin client and virtualization. And with this we provide services through a web server. So in this way our applications and our services can be installed onto a web server, and the client can then access this for its applications. So this is what we have, in that we can have bare metal virtualization, such as with VMware ESX, and then we can have virtual images set up for our operating systems, such as for Windows and Linux. So these are run within inside a server cluster, where we have a single interface, and then we can create these images within inside our cluster so that they run on a machine within inside the cluster. At any given time we can then create new images if we require, and we can also delete them. So we can also have our virtualization done where we have a base operating system and then we install our VM image on top of this and then run our operating systems and services. This method obviously has an overhead compared to this method. And then we can also have our own localized VM image where we can have our base operating system and then we run our VMware image and it uses network address translation to be able to communicate with the outside world. So what are the main infrastructures that we can have for this new type of distributed computing? Well, obviously we can have multiple cores inside our machine. So in this case we might have 4 cores for our processors, so it's possible to run tasks on each of these 4 cores as long as they are organized and synchronized together. What we can also do is we can use a clustered machine. So in this case we might use VMware ESX and we can give a task to this cluster. The cluster behind it has multiple machines. So if one machine fails, then the other machines will take on the task. And then this can run in parallel or can use the resources of the cluster. So typically we focus around multiplying up CPU, disk space, memory and so on. We can also use grid computing. With grid computing we can have multiple devices across a wide scale network, typically geographically distributed. A cluster tends to be localized and using the same types of machines. So in this case they might all be using Windows or they might all be using Linux, where grid computing tends to use different types of machine distributed across a large area. And then we can have a cloud interface, and in this way we can create our services when we require them. So we might have server creation, we can create a server when we want it, we can then consume it and then delete it as required, or we might have storage creation. So in this way we get a flexible and ever-growing infrastructure. These types tend to be fairly fixed and it's difficult to scale them up and down, but with a cloud infrastructure we can actually create dynamically new services inside the cloud and consume as required. We'll see that this tends to lead to a pay-as-you-go model where we pay for the services that we actually consume. So before we look at cloud computing, we'll have a look to see where we have been with grid computing. So with grid computing what we have is that we have a client who wants to complete a task, and that task could then be split into a number of different threads. The synchronization of these threads is sometimes difficult, but if we have a scalable application, then it's possible to split a task into a number of threads. Then we can have a grid layer, which is our middleware, and our middleware will bring together a number of machines across the internet. So typically what happens is that we use CPU scavenge it. So if a machine isn't actually being used at the current time by the user, then it is possible to use its CPU. So many applications of grid computing use the CPU when the screensaver is on the computer. So it's then up to the middleware to then assign each of these threads to different machines through some sort of CPU scavenging. So the way that it normally happens is that there's some decoupling of the client from the actual allocation of the task. So in this way we can submit a job to a data manager. We then push that data to a messaging queue, and then each of the workers watch the queue. First one to pick up the message, will then download the dataset, run the task, and then publish the result back into the message queue, which is then sent back to the data manager. So let's look at an application of grid computing. So let's say that we have a 64-bit encryption key, and that leads to 1.8 times 10 to the 19 different combinations for our keys, which is 18.4 million different keys, from all zeros to all ones. So let's see how long it would take to crack the key by brute force if we had to search all the keys. So if we take an example here, then on average it will take us half the time. So we might be lucky and get it first time with the key space, or we might have to go to the very end to actually find the key, but on average it will take us half the time. So if we take a fast computer, and let's say it takes us 1 nanosecond to actually search each of the keys, then it takes about 9 billion seconds, or 150 million minutes, to actually search on average for the key, 285 years. But what we find is that our computers typically increase their power each year. So if we say that a computer increases its power by 2, so it takes half the time to process, then we can see here that every year it reduces by half. So then after about 8 or 9 years it's only taking 1 year, and it drops even further until in 17 years it only takes 1 day to crack what took us 2,500 hours. With grid computing we can scale even better, in that what we can do is that we can set up our grid. So our grid might involve 2 computers, and with that we can send half the keys to one computer and half the keys to the other. So we should find that the total time to compute will go down to a half. Then we could set up a grid of 4 computers. Each we could give a quarter of the key space, and again the time to compute will go down to 1/4. With a 4x4 or 16 element grid, we would go down to a 16th, and then for a 16x16 we would have 256 processing elements, and again the processing time would go down to about 1/256. Okay, so we can see here that if we take into account the increasing processing power and also increasing the size of our grid, can significantly reduce the amount of time it takes to crack the code, which took a long time on a single processing element. Over time and over a number of processors, it can be brought down considerably. So an example of grid computing is the distributed.net software, and they have issued a number of challenges for the research community. So one of the first one was a 56-bit RC5 encryption challenge, and it took 250 days to crack the code. Then in 1998 there was the 56-bit DES2, and it took 39 days down to 2.5 days. Then in 1999 the parallel processing machine called Deep Crack cracked the DES code within 22.5 hours. In 2002 there was a 64-bit challenge for RC5, and it took approximately 1700 days, and the current challenge is for a 72-bit RC5 encryption. How distributed.net works is that a number of computers install the software, and then when the screensaver comes on, then a number of keys are downloaded into the computer and searched through. So we can see in this case that the screensaver has went on here and then is switched off. So this is normal activity, then it's switched back on again when the screensaver comes on, and then off, and so on. So in this way we can actually harvest the CPU resources which are often wasted. The main focus of this presentation is to look at cloud computing and its infrastructure. So with cloud computing we can get a number of different levels at which we can integrate with the cloud. At the lowest level we can have hardware as a service, so we can actually subscribe to external hardware if we require, and then get the hardware as we need it. So this allows us to reduce our capital investment and also enhances our failover capabilities. Normally though we get infrastructure as a service, and with this we get the switches, hardware devices, network firewalls, and so on. And in this we can have resource virtualization, we can get storage capacity, define network bandwidth, and normally have a pay per usage scheme. So as we'll see later, an example of this is the Amazon EC2 cloud. Above that we can then define platform as a service, and this is where we start to get our service oriented architectures, where we can integrate web services and build applications around them. So examples of this include Google's engine and the Microsoft Azure cloud infrastructure. So at present Microsoft has applications at this layer but do not have anything at this layer. And then at the very top we can have software as a service, and this allows users to create their own software applications. So with infrastructure as a service we might use the Amazon Web Services, and with this we can actually start up virtual machines inside our cloud. So we might log on to Amazon, create say 3 new virtual images, set up our firewalls to be able to access them, and then we can remotely log in to be able to access their services, run a web server say, and then that can then be consumed externally. We can then have platform as a service, and this is where we see the Google Application Engine, Amazon EC2, and Microsoft Azure. So with this we can create users, we can use a data storage service, and even use a security service. So typical protocols which are used in here are SOAP and WSDL, which are used to find services, but as we'll find, RESTful services are also widely used. Again, we have an API to be able to interface to our services and then bundle them together to create our applications. Then at the top level we can have software as a service, and this is we see examples of email packages such as web-based Outlook, Gmail, and so on. We can have Office packages and applications such as Twitter, and in this way we get an application web interface and the user can actually design their own software around this. Again, we look at a pay per usage type basis for this. So let's look at a real cloud. The most advanced cloud that we can have is the Amazon EC2 cloud. And basically it's built around a number of key application areas. The core of it is the Amazon EC2 or Elastic Cloud, and this gives us an interface to the Amazon cloud, which includes data centers in the US and Europe, using the Xen hypervisor to be able to manage our servers. We can also have the simple storage service, or Amazon S3, and then that enables us to store data into the cloud. As we'll see, it brings in the concept of bucket areas for our data. We can also have Amazon SimpleDB, which allows us to create our web-based databases, which allow for structured data storage and should, with the improved reliability of traditional databases. We can have Amazon CloudFront, and with that then we can place our content at the edge of the Amazon cloud in order that it is close to the place that is actually consumed, to allow rapid delivery of content. And then we can have, in the same way as we've seen with grid computing, a simple queuing service where clients can actually post messages to a queue which have a number of subscribers, which will then listen to the queue and then consume them. So this is an easy way for us to post messages to a number of servers. The way that many cloud applications work is to use a simplified web architecture of RESTful web services. And with this, we move away from the typical URL, where we can actually pass parameters, towards a resource-focused approach. With this, the resource is identified inside the URI. And what RESTful does is that it simplifies our SOAP model and allows HTTP to be used to be able to create, read, update and delete our resource. So what REST does is define the way that HTTP requests are used to be able to implement the CRUD. So if we want to create a new member inside a collection, so we want to create, say, a new database entry, then we use the post HTTP command. If we want to read, then we can use the get. If we want to update a member of a collection, then we use the put. And if we want to delete, then we can use the delete HTTP command. So in this way, we can use a stateless approach where the web service doesn't have to remember any accesses from before. So everything is we post a request and then get a reply. So there is no need for any stateful interaction. So this keeps it fairly simple. So RESTful services are often replacing SOAP and WSDL for web infrastructures and are used by Yahoo, Facebook, Amazon, Microsoft Azure and so on. So let's have a look at the Amazon S3 Simple Data Storage Service. So with this we get the concept of buckets. So the storage services do not create a hierarchy as we would get in a file system, but create a number of buckets. These buckets have namespaces which are unique across all the Amazon Web Services. Then we can then put and retrieve our content into those buckets. So one way to do this is to use the S3 command language. So this creates a new bucket. In this case, build.bucket is the bucket we're creating, and that should be a unique namespace. We can then put files into that bucket using the put option, and then the get will get them back. We can list all our content inside our buckets with the ls and list a specific one, and we can also delete our content using the delete option. So typical cost is $0.15 per gigabyte per month of the storage actually used. So the first concept that we need when we are accessing our account is that we need our access ID, and so this will be used to access the web service for storage. And then there is also a secret access key, so we can click on that to actually show the access key. From here we can then go to our application, and our application has our access key ID and then our secret access key. So in this case it's a simple example to be able to consume our data storage. So we'll just run it and we'll see what the results are. This is the Windows option, so we'll go for console application. Initially, and we just need to find the console. This is this one here. Have to stop our program first. Okay, so once we run the program, then we're making accesses to the API. Okay, so the first example will create our bucket. So this is a unique name that we're creating across the Amazon Web Service Cloud. We can then list the contents of the bucket that we've actually created. Okay, so we can see here the result is in XML, is an XML format coming back. And then we can create another bucket and list the contents of that. We're going to create a string object inside one of the buckets, and then we can get that back from our bucket. Okay, so in this way we can actually access our buckets from our application using API calls. We do the same with a form, so we'll set that as a startup project. Okay, so here are all our buckets, and we've stored a string object in there. So we can see here we can then use this application to then upload our files into our area. So in this case we've uploaded test.txt into one of the buckets that we have. So the buckets, as we said, are unique to Amazon Web Services. So let's look at the Amazon EC2 Elastic Cloud. So with this we get the concept of an Amazon machine image, or an AMI. And an AMI is an image, is a bit like a class definition inside an object-oriented program. So we create an abstraction of the image that we're going to actually create. So with this AMI, we then create instances, and we can create multiple instances. So in this case, we've created 2 instances of our AMI. So our AMI can be Windows or a Linux image if we require. So we can do this by creating our AMI and then launching an instance, or we can from the web interface, or we can do it from the command line tools. So in this case, we're actually running an instance of our AMI. So we normally manage our instances through the web interface. So in this case, we have an instance that we've created based on an AMI. We can see it's running at the current time. This is the address that we can access it through the remote desktop. We then have a security group, and this is where we can enable services and disable them. And then we have what's called a key pair. When we first register for our Amazon account, we get a private key which is stored in a PEM file. If we need to restore usernames and passwords, we can recall that private key back and recover details. So we can have our basic monitoring of our service and a description of it. So what we see is, let's have a look now at our management console. So we can see in this case we can launch an image if we want. So there are many ways, many systems that we can actually create, so including Windows and Linux. On our dashboard, we can see we've got one running instance just now. We can get an IP address that we can allocate into our virtual images. We have security groups that we'll see in a little minute. So let's have a look at our instances. So in this case, we've got one instance running based on this AMI, and this is the address here that we're going to access it with. Okay, so from here we can reboot our image, we can stop it, and we can even terminate it, and we can look at the log of it too. Okay, so for this image, it's running just now, and we'll just have a look to see how it's doing. So this shows us CPU, network utilization, and so on. So this is our CloudWatch function here. Okay, so let's now access our remote instance. So we'll just copy this, bring up our remote desktop, and then we'll connect to it. So it should prompt us for the password. And hopefully we'll be able to get in. So this is a server that I've created already. So what I've done is I've added in IIS as a role. Okay, so this is our remote desktop here. And if we look at our server management, hopefully what we can see is that we've added an IIS as a service. So what we're going to do is we're going to access our web server from outside. Okay, so it just takes a little minute. So you can see here, when you want to add in a new role in Windows 2008, you can go to this page, and we can see here I've installed IIS. So if you want DNS, DHCP and so on, then you can activate them here. So I've added in a new role of a web server. So I just cancel this. Okay, so what we should see is that we should have an inet pub, a www root, and here is our IIS start page. So we'll just edit it in some way. Just put something in there just to make sure that we've actually created this page. And we'll exit. So now to test that our web server is running, we can do the localhost. And we can see here that the web server is working fine. So let's try and access this web server from outside and see if we can actually communicate with it. Okay, so that's our DNS for it, and hopefully if we're all firewalled, then there shouldn't be any accesses to it at all. So what we'll do is we'll now enable our services for it. Okay, so we can then go to our security groups, and the one we've applied is here. So now what we'll do is that we'll enable HTTP access to it here, and we can lock it down if we want to certain addresses, but we'll just make sure that everybody can get access to it. So now we'll save that, go back here, and we couldn't get access to it, so hopefully now we can get access. Okay, so just to show you that there was no smoke and mirrors here, we can actually remove that. Okay, and still there. I think because it's cached, but you can see that what we've got to do is we've got to then enable our firewall to be able to get access to our server. Okay, so our server is running quite happily here. We can run, we can create various images and then get them instantiated. Okay, so a key concept is by default only the remote desktop is allowed access to our virtual image, so it's firewalled. So if we need to enable web access, then we need to enable the HTTP service on it. After we have that, then we can see that we can then access our server from any location. We can lock this down to certain IP addresses. Okay, so the great thing about the Amazon EC2 Cloud is that we can interface our own applications into it using an API interface. So the ways that we can do this is that we can create our machine image, and then we can create instances of it. Either we can use the our own API calls, or we can use the EC2 command line images. So in this case, this is the EC2 command to be able to list all the images of a certain user. So there are a whole host of EC2 command lines that we can actually use to create instances, delete them, and so on. So in this case, we're actually running 10 instances of this AMI. So let's have a look at an example of some code to be able to do this. Okay, so this is just some code taken from the Amazon site. Okay, so we'll put in the password first, the secret access key, and we'll just find the username. Obviously this can be automatically configured for users. And I just put in a little breakpoint there. So this should run, hopefully. Okay, so this shows our little demo, and you can see here this is showing what we saw before. There's our DNS name, you can see it's running, and so on. So if we wanted, we could get our image ID from here, paste it into here, and then we could actually start that image running, or we can actually reboot it. So in this way we can create applications based around most of the programming languages. So this is based around .NET, and we can use this to actually interface to the cloud. Okay, so this is giving you an introduction to cloud infrastructure. So we had a look at clustering, grid and cloud systems. We then looked at some of the advantages of grid computing and an application, and then went on to look at how we can use infrastructures, cloud infrastructures, especially around the Amazon Web Services. Okay, so that's given you a general introduction to cloud system.